In this video, we are going to visualize our thinking model, except now we are going to use pointers. This allows us to be able to remember by reference. So when we start out this type of problem, we're always going to write out our three memory types. So we have our stack, which is our hippocampus. Then we have our registers, which is going to be our working memory. Then our data heap, which is going to be our neocortex. And just a reminder, the hippocampus, it's good for cramming, short-term information, allows us to remember tasks, good for functions. Registers, it's like our working memory, you remember 8 to 12 things. They work very fast. And then with neocortex, you have to train it, but it stores elements in the long term. For now, we don't have anything that we are putting into our data heap, but that is okay. We're going to develop a good habit by drawing it out now. So that way, when we go and build things like singly and doubly linked lists, this becomes very helpful. Just like we've done before, we check our input and output registers first. No input registers, and we have an output register in main, which tells us to return 0. So we always put the functions on the bottom, and then we do return 0. And then we go through our code and allocate. So here we have allocating a register of int x and equal 5 and register int y is equal to 7. So I'm going to say main.x is equal to 5 and then main.y is equal to 7. So now we create a swap function. Swap, we have registers, but they contain the address of pointer x and the address pointer y. So what does this mean? We stored the value of the address of x and the value of the address of y in these values that we're pointing to. So we call a function swap. One last thing, we don't have a return register. So what I'm going to say is swap dot pointer x is equal to the address, and we're going to say ampersand for simplicity, main x. And then I'm going to say swap dot pointer y is equal to the address of main.y. And then I go to function, register int temp is equal to the value at pointer x. So I say swap.temp is equal to the value at pointer x. So here's what it says, value at pointer x. What that means is I go to the value at pointer x, which is ampersand main x. So I go here, it's a pointer, and that's equal to 5. So I get a copy of that, and I say that's equal to 5. Then I say the value at pointer x is equal to the value at pointer y. So the value at pointer x, which is currently pointing to 5, is going to be equal to the value at pointer y, which is here. So we're going to go here, this is a value at pointer x, and make that equal to this value, which means we're changing this to 7. So there you go. You see the value at pointer y is put over to the value at pointer x. Then the last one says value at pointer y is equal to the value in temp. So pointer y is here, so we point to this location. And then we would say it's equal to the value in temp. So we copy that over. Sorry, this is pointer Y. And then we change this value to 5. And we performed a swap. So now 5 and 7 have been switched. The function is done. So our next task is to get rid of the swap function. We free it. And then we free these registers. Like so. And then if we wanted to print out the result here, we could print the results. But then we get here to the end, return 0. Return 0, we reach that brace, which means that we free main and we free the registers. So now we have cleaned out the memory and we are ready for the next program.